So this data analytics course is designed to equip students from ground up. No special prerequisites, professional knowledge or skill is required, apart from the ability to use the computer and basic office productivity software. Okay. So the course modules includes fundamentals of statistics, advanced Microsoft Excel for data analysts, SQL, and database management systems, Microsoft Power BI, that's for visualization, and then R or Python programming. We're actually using Python in this case. Okay, so these are the things we are going to do in this course. And when I say fundamentals of analytics, that is mostly essentially that's mostly like statistics. Okay, yeah, statistics, because statistics is the foundation of analytics. Statistics and a little bit of algebra. Okay. All right. So to be a successful professional data analyst, you have to be very effective in using some software tools. In this course, the tools used are Microsoft Excel, SQL, that structure query language for databases. Okay. We have Power BI for visualization. Visualization has to do with summarizing and reporting, creating reports and dashboards by using visual, mostly graphical tools, okay, for presentations. For example, you can create a report or what we call a dashboard, which we will learn as we move on. Maybe using things like pie chart, bar charts, graphs, XY scatter plot, line charts, cards, and all that. So, you use Power BI to do that. Such things can be done in Excel, but Power BI does it much better. Okay. And of course, Python is a programming language, okay, which is a very major component of this particular course. The Python programming language, of course, I'm stating here that it's optional, but um, it should be advantageous for us to do it. There are some people that do this course and say they don't want programming and all that. So, well, that's why it's there as optional. But if you can do it, it's better. It's better. Okay. There are lots of opportunities for people who can use Python. Okay. Students who are interested in coding are encouraged to attend the Python classes in addition to other course modules. All right, so, well, they said the journey of 1,000 miles begins by taking the first step. So I think you have taken your first step. So you have just started your journey to becoming one of the world's great data analysts and possibly data scientists. Okay, because from data analytics, you can easily transit into data science. Okay. Yeah. As you move on, you will understand how that happens. The journey of 1,000 miles begins, okay, by taking the first step. Well, congratulations. So any questions so far? Any questions? Any questions?
sir.
Yeah, please go ahead.
Okay, sir. Can we get access to the recording of
Yeah, I
this?
can, yes, I can send it to you. Yeah,
Okay,
yes,
sir.
you can get access to it. Don't worry. Yeah. Okay, so now, if you don't have any questions, maybe I should ask you some questions, right? Well, not about what we have done. I think everything we have done is easy and straightforward. So, can we all, it's just two of us that are here right now, okay? Okay, so we talked about the tools that are used to be a data analyst, a good data analyst. The first thing, of course, you have to be used to some of these tools. The most basic one is Excel, the most basic one. The most basic tool is Excel. Excel is a very simple tool, but very, very useful. Okay. It's easy to learn, but it can be used to do, a lot of nice things. Okay. And you also need to know that when we talk about analysis, it's not in every case that we go through all of these. Not in every case. Okay. For example, let me give you an instance. There are some cases where the job you are required to do may not entail modeling at all. There are cases where you don't have any business with modeling. Okay. As a data analyst, sometimes your job may just involve maybe you get the data, you summarize the data, and then just do some presentation. Okay. Sometimes it's just as simple as that. Just do presentation of the data. Okay. That may just be all that is needed. Do you understand? For example, and in that case, now, and that's more like what you do, like in this, because when you are exploring data, what you're actually doing is you use, mostly these presentation kind of tools. For example, you can use histogram to see what data looks like, those kind of things. So the all that may be needed is just get the data, summarize the data, and maybe plot some charts, maybe pie charts, bar charts, and that may be all. So the next thing is the interpretation of the results of those charts. So you don't always have to do data modeling, right? But looking at it from this perspective is like looking at data analytics from the perspective of a data scientist. Okay, so that's that. So that shouldn't cause confusion, because most of the things that analysts do, people who are called analysts, many times it doesn't involve modeling at all. So take note of that. That shouldn't cause any confusion. Like I said earlier, analytics is a very broad, it's a broad term. It's a broad term. So there are different perspectives from which we can look at it. Okay, but we are trying to handle it from a kind of a deeper, a strong viewpoint, which is like, just like a data scientist, the analytics that may be useful to a data scientist. Of course, we won't do it to the level of data science. I will, as we go on, we'll talk about that. Before the end of this course, you will, you will realize, what the difference of the job of a data science and the difference of a job of a typical data analyst is. All right, so that being said, now to be a good data analyst, one, you must understand the fundamentals. You must, these fundamentals. This is one area where many people who claim to be analysts, many of them are deficient in statistical principles. Many of them. That's my personal observation. Okay. So when we are learning the statistical principles, you have to realize that they are very, very important. Okay. They are extremely important. Extremely important. I give you an example. For example, one of the things we learn, one of the fundamental topics is classification of data, types of data. Okay. There are different types of data. Data can be classified into various forms, types. There are different categories of data. For example, we have numeric data. We have categorical data. Those are two broad classification. Okay. Now, you should know the difference. Of course, there are sub-classifications. You should know the difference, and you should know when to use which. You should know the kind of analysis to do on each type of data. You understand? So those are very important because as an analyst, you take various decisions as you move on with your job. You take decisions, make various decisions. Okay, so your understanding of the basics is what forms is what informs your decision. It's what helps you to take the right decision. Decision as to the right, for example, the right model to use, the right processes, the right kind of transformation to do, and those kind of things. So it all starts from the foundation. Okay, but a lot of people are not interested in that foundation. They just want to learn Power BI, okay, to do beautiful visualization. They want to learn Python. They want to learn SQL, but not realizing that this this statistical thing is the real thing, right? You are just using all these other ones as tools for implementing the real thing. Okay? So knowing the tools without knowing the principles of analytics itself is just like a doctor that knows how to use the stethoscope, but does not really understand how the human body functions. Doesn't know anything about anatomy, but he just knows how to use the medical tools, but he doesn't really understand the human body. Okay? Or like an engineer that can use engineering software like CAD, like AutoCAD, or like what do you call them? Architects, an architect who can use AutoCAD for analysis, for design, for drawing plan, house plan, but does not really understand the principles of architecture. Learning to use AutoCAD doesn't make you an architect. Okay. It's when you get to go to school to study architecture. That's what makes you an architect. Not just anybody can learn AutoCAD. Can learn AutoCAD in 2 months. After the 2 months, you don't automatically become an architect. So it's the same thing here. Okay. So pay attention to the principles. Pay attention to the principles. That's what differentiates the professionals from the quack. Okay, that's what differentiates you as an expert. Okay, so please let's ensure we do that. Okay, so for the remaining the time left, what we are going to do, I would like us to let's just play around with in Microsoft Excel environment.